Hey guys, Issa with Journey to Programming here. For the last few weeks we've been doing an on-the-road series where we're talking about implementing simple game mechanics. What I want to do today is give you guys a more in-depth look into how we would implement those game mechanics we've been talking about. That way you have a little bit more support and a tutorial to go off of. So what we've been talking about is implementing simple mechanics for a 2D game or a 2D platformer game. And specifically, we've been making something very simple, something that moves left and right, and Unity3D has the ability to either jump or move upwards on the platforms, and then the ability to fall. So what I wanted to do today is take the steps to show you guys how to set this up in Unity3D. So you guys should see right now that I have a Unity3D project open. I've gone ahead, I've made a blank project from scratch. I've already made it as a 3D project. You can make it as a 2D or 3D, but if you want to follow along with this tutorial, you may just want to set it up as a 3D project. I've called it ISGM 2D Platformer. So, implementing simple game mechanics, 2D platformer. This is going along again with the series we've been doing on the road for the past few weeks. And let's go ahead and jump right in. So, I'm expecting that you have worked with Unity a little bit in the past, but I'll go ahead and give you a quick kind of synopsis on what this engine is. So this is a game engine. This is basically simplifying the task of creating the visual pipeline and all of the rendering code for you by using Unity's APIs, and it allows you just to create objects in 3D, go ahead and import your own objects, add programming to it, and create all the game mechanics to make things work. So what you see here on the left half of the screen are two different windows. Currently, they're showing 3D world space. On the left-hand side, you have a game window. You should see my mouse right now hovering over the game window tab. This is going to show what the camera in your game is currently displaying. Next to that, you can kind of see this vertical border here. This is going to be the scene window. The scene window is showing what's currently going on in the 3D space in the actual editor. Currently, there's nothing in our game, so you see really nothing out here. You do have a camera and a light source. That's what's currently being shown by these icons here in the scene view. So you can see a camera icon there, and what looks like a sun icon, but that's just a directional light in Unity. And then moving on, you have another vertical border here. And you could see a few more windows, which have tabs named here, Hierarchy, Console, and Project. Lastly, we have an Inspector tab here. This is another window we'll talk about in a minute. So let's go ahead and jump into what the hierarchy is. The hierarchy is showing you everything that's currently in your 3D space, okay? So we just said that these icons in the scene view, which again, the scene view is displaying what's currently in the engine that you've placed in there. We could see right now that there's a camera icon and a sun icon. So it's a light and a camera. They are both in the hierarchy, as you can see here. Because they're in the scene, they have to be in the hierarchy. Okay? Now, there are kind of more technicalities to that later on, which you'll notice. You can have things that are not in the hierarchy at one point, but then do come into the hierarchy later on, and that's usually when you're creating objects at runtime, or if you're loading objects all at start. That's how you would do it that way. But we'll talk about that, or you guys can ask that question, and I'll create another video at a later time. Jumping back into this, we have a main camera and a directional light currently in our scene, so that's what shows up in the hierarchy. All right, the console. It's a console window. If you've programmed before, you're used to seeing this. If you want to see another type of console window and you're on Windows, you can go ahead and open a console window using the Windows CMD. So you can go to your Start menu, type in CMD, it'll open up a Windows console window. And on a Mac, you should be able to open a terminal. Terminal is basically the same thing. There's just a console window. It's going to be used to spit out compiling errors or issues, any kind of text that you're outputting to do debugging, and that's what you're going to have there. Next, you have the Project tab. The Project tab is basically your file directory. So it's going to display any files you have in your project files or in the assets folder. and then it'll just kind of keep on building. If you want to add plugins, they'll show up in here. If you want to add resources, you could load in at runtime. You'll have a resources folder that will show up in here. There's a whole bunch of good stuff that will show up as you begin populating your project. Your assets like graphics and media should be in here too. Right now, this is a blank project, so all you have is a sample scene, nothing in your assets folder, which is the root directory, and then packages are just the standard packages that come with Unity right out of the download, okay? So, just to also clarify, I'm using the most up-to-date stable version of Unity. So I just downloaded this yesterday, which would have been January 6, 2019. So I'm using 2018.30 F2. Okay, that's the most up-to-date stable version of Unity. Unity does have a alpha version out right now for 2019. I prefer to stick with the stable versions when I'm doing professional development, so that's why I've stuck with the stable version, even though there's a newer version currently out. Okay, I don't like to use alphas unless I'm experimenting. All right, so let's just jump into this. So we talked about creating a simple 2D platformer in the very first episode, and the first episode, in the first episode, the goal was to create left and right movement, to create an upwards movement, and to allow your object to possibly fall. Okay, the first thing I told you guys to do is to go ahead and begin populating your level with some sort of ground. All right, so what I'm going to do is very simply, I'm going to create a cube in my scene. You can see that now it's in the scene view, but I don't see it over here in my game view. Oh, now I do when I expand the window, but it's not in the direct vision of my camera. So what I want to do is I want to make sure that the cube becomes the ground in front of my camera. All right, and the way I'm going to do that is I want to place it directly in front of my camera, and I could do it in a few different ways. I could either manipulate its transform component, which is here. I'm currently hovering over it with my mouse. Or I can manipulate that transform component out of the inspector directly in the scene window by using its basically up and down arrow, right and left arrow, and then depth on the z-axis arrow. So this allows me to move the cube through the actual 3D space. You can see it coming within view of the camera. The other way of doing this is we could move the camera to position around the cube. So if I click on my camera object, I begin to see an outline in the scene window, which, once again, the scene window is like an editor view. All right, I'm going to expand that scene window so you guys can see it a little bit better. It's an editor view. You're seeing what the camera could see, then you're seeing everything in the 3D world that you currently have. In an empty one, we only currently have a main camera, a directional light, and a cube. That's what we see. In the game window, you're seeing what the camera is seeing. So that's what, if you were to build this application and, say, release it on a Android phone because you think this is a cool game, the thing the user would see is just a cube sitting in front of them, okay? So going on. To place this object, what I want to do is I want to move the cube itself rather than the camera. By clicking on the camera, I can see what the camera is currently looking at. I can see its perspective angle right now, or orientation. What I want to do is I want to place the cube in front of the camera using the camera preview, using the fact that I could see the perspective outline that the camera can see, and then I can manipulate directly. I can manipulate the cube directly using its transform component here in the inspector, or the arrows on the cube in the scene view. Okay, I'm going to move it in front of my camera like I've done, and now what I'm going to do is I'm going to make it a platform on the bottom of my screen. And what I'm going to do is I want to extend this to be the ground floor, but I want to give my player more room to run. So I'm going to pull my box out by pushing it further away from my camera on the z-axis. So if you see, I'm dragging it further away using the blue arrow on the z-axis, or I can manipulate it using the inspector variables here by clicking on the z coordinate and dragging it out or in. I'm going to go ahead and also just place it at a point I directly want it to be. So I'm going to specify I want it to be at 10 units on the z-axis. All right. Giving it that much depth now puts it kind of in the center of our camera perspective. So what I want to do now is I want to push that down to the bottom of my screen and make it a ground platform. Okay, great. So now I have the cube at the bottom of my screen. It's kind of acting as a floor platform. Okay, what I'm going to do next is I want to make that platform wide enough that it fills my screen from the left to right edges. So I could do it in a few ways. I can duplicate this cube and kind of fill it by doing something like this. So I duplicate the cube and I move it over, do it again, and I move it over. And then I do this on and on and on until I fill the screen from the left edge to the right edge. I don't recommend doing that because you're creating a new object for each one of those cubes, so a new cube is being rendered each time. I'd rather, I'm just undoing it using Control Z, I'd rather just scale the cube on the x-axis until it fills my entire width. I'm going to make it a little bit wider, as you can see here on the perspective camera in Editor. I've actually made it a little bit wider than I need to. See? But I'm doing that just to make sure I fill from edge to edge. It's not a problem. For right now, we're just going to test that basic functionality we talked about. All right, so now we've created a cube, and I'm going to make that my ground kind of floor for my player cube to move around on, all right? What I want to do is I want to at least label this correctly. So if I click on my cube object in the hierarchy, I can rename the object. I can either right-click on it and go to Rename. I can go over to the inspector where it's named and rename it, or I can click once and keep my mouse on it and allow it maybe 2 or 3 seconds for it to select the actual name, and then I can rename it there. So I'm going to rename this ground, press enter, and now that's become my ground object. I'm going to hit save just to make sure that we've saved our progress so far. And the next thing I'm going to do is I'm going to create another cube object to be our player. All right. So you can see in the scene that we now have another cube. And what I'm going to do is I'm going to make this cube line up directly over my ground floor. The fast way of doing that is I know my ground is currently at 10 units on the z-axis. There we go. And because I can visually see how this lines up using my scene window, I can already tell that my cube is floating a few units on top of my ground. So that means if I press play right now, my cube is just going to be hanging there. We haven't programmed any functionality. We haven't really added any physics. We haven't done anything. My cube should just sit there. I've pressed play in Engine, which simulates this running as an executable. And you can see my cube isn't moving. I can't click on anything, and I'm going to tap my keys pretty hard here. Pressing keys does nothing for me right now. Okay? So what I'm going to do is I'm going to stop playing Unity, and I'm going to do that by hitting the play button again. It stops play mode. And I'm going to go back to this cube, and I'm going to move it down a few units because this is supposed to be a player that's going to be starting on the ground floor. All right? So you can see shadows are being created because we currently have a directional light in the scene. Here's our light. If I click on the directional light object in the hierarchy, that shows us the direction that the light is currently casting its light in. And if you look at our shadows, since this is pointing kind of in a downwards angle forward here, our shadows being corrected, our shadows being thrown in the correct location or the correct direction. That's great. So now I've moved my cube down, so when we actually do create some functionality for the cube to move, it's going to be closer to the ground floor and look more realistic. What I'm going to do now to begin implementing that functionality is, first things first, I'm going to add something called a Rigidbody Component to my object. What that's going to do is it's going to give us a very simple way to prototype this functionality by using the Unity physics engine. All right. So if I add a Rigidbody component to my cube by going over to my inspector, which I really haven't covered very much yet, then that's going to give my cube object physics, and it's going to allow it to fall onto the floor when I press play. All right, so that segues into, let me talk to you guys a little bit about the inspector. So this inspector window, we've already been playing around with it. The inspector window displays the characteristics and definition of the characteristics for a game object, okay? This cube that we've created, which is ultimately going to be our player cube, has characteristics defined to it. It has a transform component. That's what this is here. So if I minimize that transform component, it hides its characteristics. But these characteristics define that cube. Okay? If I manipulate them here in the inspector, it will manipulate the object you see on screen. So if I scale it up on the x-axis, you can see it's manipulating. If I scale it up on the y-axis, it's manipulating. Great. Next, we have more components which define additional characteristics for our game object. All right, so a cube has a mesh filter and a mesh renderer. These are drawing your object on the screen for you. Okay, we could talk about this later on. You could do a bunch of fun manipulation to objects at runtime if you ever want to. For example, maybe you have a really basic object in the beginning and you have them look more defined if you're zoomed into them, and you're playing with like level of detail LODs, then you may want to be doing some swapping of the actual meshes at runtime in order to add more detail when somebody zooms in on a player, and then reduce the detail so that your performance is better at runtime when they're not zoomed in. Okay? Next, we have a box collider. So a box collider is kind of explaining what it is already. It is a component within Unity, and there's a ton of different collision components, like you can see here, that detects collision in Unity's engine, and it does it automatically. All right, there's tools and APIs to give you additional control over it, but the whole point is using a collider on an object allows you to write code that will trigger something to occur or an event to occur based on something hitting that object's collider. Okay, so it is going to be used to trigger events to occur when something hits the collider that is on your game object. Our ground object has a collider on it. If we zoom into our ground object, we can see that there's a green outline to it. That is the current shape and scale of that box collider. It's fitting to the actual cube. If I disable the mesh renderer on that object, it's not going to render the filled cube anymore, but the green outline will remain because the collider stays there. Okay, if I disable the collider, we no longer have a collider. We just have a very light green outline, and this is just showing that that has all been disabled. This is where the cube technically exists. It's the shape of it, but it's dimmed, therefore it's not on. If we want to disable the entire game object altogether, so it's no longer being used in the scene, we could possibly control it later on via code to turn it back on, but for now it's off. We can go ahead and uncheck this box up here, which is going to disable it in the scene. There you go. I'm going to go ahead and check those back on because that's not something we need to be worrying about too much right now. But what I want to do now is I want to add that Rigidbody component, which, like I was saying, by adding a Rigidbody component to my cube object, which is going to be our player, it's going to give my cube physics using the Unity physics engine, okay? The next thing I want to do, after you've added that Rigidbody component to your cube, I want you to rename your cube to player, and then I want you to hit the play button. When you hit the play button, you should have noticed a subtle drop by your cube. Okay, I'm going to do this again. Pay close attention here. In the scene view where I'm looking at the cube in the floor or in the game window, you'll notice the cube drops when I press play now, because we now are applying physics to our game object, and automatically by default, Unity keeps gravity turned on in its physics engine, and you have to disable it manually, but because it's on, our cube now has gravity on it. So if I press play, it's going to try moving downwards, which it does. You saw a subtle drop. So great. If we are thinking about this in an implementation way, then we just already implemented that drop functionality. If I bring this cube up here, you notice it falls. All right, so the drop functionality being, if you're Mario and you're jumping up on top of cubes, Mario needs to be able to fall from a platform. And Unity's engine already sets that up for you. It may not be perfect with how you're going to create your game, but it's a good rough prototyping functionality, which you don't even have to write any code for. All right, so I'm going to go ahead and stop playing in Unity, and I'm going to now begin writing the code to detect the input so we can begin moving our cube. So what I'm going to do, just for formal sake and keeping my project tidy, is I'm going to add a new folder to my assets folder. I did that by right-clicking on assets, going to create and adding a folder. You can also do that by clicking on assets, going to the create button, and then clicking on folder. I named it scripts, and within here, I'm going to create a new script by right-clicking, going to create, and clicking on C# script. Okay, the other options, I can click on scripts, go to create, and add a C# script. I'm going to name that simple movement controller. All right. Once that's done, you're going to see some code displaying to you within the inspector, just to give you a preview of what's in that file. But what you need to do is you need to double click on that script. It's going to open Visual Studio for you. And then we need to begin adding the code into it. Okay? When you open the script, and I'm going to go ahead and do a quick swap between windows right here. When you open the script, you should see that it's already pre-filled out with the Unity standard mono behavior calls. So the start function and the update function. All right. So the start function gets called at the start of your game. When you hit the play button, this is going to get called one time. You should do your initializations there, references, and the following in that function. The update loop runs per frame. So this is your update loop. Anything you write in here will be running constantly throughout your game. So you want to be careful about that. But you're making a game. Hopefully you've taken a game development course or read a few books. Game loops are core to everything. So let's go ahead and talk about creating that basic input so that we can begin moving our cube. All right. So what I talked about on our podcast was you can use Unity's API set to detect input from a keyboard or a joystick. I'm going to show you how to use the detection of a keyboard by using the input.getKeyDown functionality, and I'm going to detect my WASD keys. So I'm going to detect A and D first in order to move my cube left and right. So doing an input.getKeyDown will return whether or not somebody is pressing a key at the frame in which they've pressed that key down. All right. So what I need to do is I need to put this code into an if block so that it reads in the computer like the following. If a user, using the if statement here, has pressed the A key, then do whatever I tell it to do in this block of code here. What I'm going to have it do is do something as a comment, and then I'm going to have it debug a message for me. So you could use two formats for debugging a message to the console window. You could use a debug.log. You've pressed the A key. Or you can, log has a capital L. Or you can use the print function, which is doing the exact same thing. And I'm going to say you've pressed the A key 2, just to symbolize this is a second print function. All right. So with this basic functionality, what we've done is we've detected if a user has pressed the A key on the keyboard at the frame in which it's been pressed down. Period. All right. What we can do now is after saving this code, we can go over to Unity, and Unity will go ahead and what we call hot load the script. So it's going to compile it when you go back to Unity after you've saved the script, and it's going to go ahead and tell you if anything's wrong. If there are any errors, it would display it here in the console window. There are any, great. The next thing I need to do so that my player has this functionality, or this functionality can actually be used in my current scene, is I have to add this script as a component on one of my game objects. Since this is going to control my player cube, I'm going to go ahead and add it as a component on my player. So you can see it here. And I'm saving my project just to make sure our progress has been saved. And now, after it's been added to my player object, if your code has been written correctly, like you see here, so we have within our update loop, which is running on each frame, we're trying to detect if the user has pressed the A key down. Then, if you press play, and then you begin pressing the A key, we should see some console log out. But we don't. So let me double check my code. And then let's go back over to Unity, make sure it's all connected. And there we go. So sometimes if you transfer between the Visual Studio source code and Unity too quickly and press play, your code may not hot load quickly enough. That may have been what just occurred right there. Since when I switched over to my code, I didn't change anything. So it may have had an issue hot loading right there. If that ever happens and you know your code is correct, just go ahead, run into Visual Studio, and what you can do is you can go to the debug button, the build button, and hit build solution. I pressed the hotkeys for that, which is Control-Shift-B, and by hitting that, you're going to compile your source code manually by calling the compile button, which is the build button, and then I went back to Unity, and it all worked. The other thing I did is I made sure that after I pressed play, I brought my mouse over to the game window, I clicked within there to give it focus, and then I began pressing the A button. So that, after doing that, I do see my output, which is great. Our source code is working. Now we're detecting the A button being pressed. So what I'm going to do next is I'm going to show you how to apply this to my cube within this if block by replacing the do something here and the print statements with a line of code that's going to apply movement to my cube so that it moves to the left. All right. So there's a quick way to do this. This isn't the most efficient way. I really should cache some of this, some of these calls, but I'm just going to show you really quickly. So this script is attached to my player cube. What I can do is I can say game object or transform dot position plus equals new vector 3 dot left. And I'm going to go ahead and define left manually here by defining its coordinates. So I want to move to the left on the x-axis, meaning I want to move -1 units on the x-axis. I want to move 0 on the y and 0 on the z-axis. Oops. And these are all floats. That's why I add an F at the end of them. And now what we should see, if I run this code, which I'll explain really quickly in a moment, then we should see my cube begin to move to the left. And it may be subtle, or it may be really fast because I haven't buffered this with delta time, but we can click on the cube object before we do this so that we can see its transform component. And if we look at its x-axis, I'm going to press A now, you can see that it begins moving left. So great, our code is working. It's now kind of leaving our screen because I haven't added code for it to move anywhere else. And as you saw there, when it got to the end of my platform, it fell. Gravity still applied to my cube, and there's no longer a ground floor under it. Therefore, it reached the end and it began falling on its own. So I'm going to stop playing now and go back to the script really quickly and show you what I did. So what I did is I used the transform component on my game object, and I said I want its position values to be changed by appending a new vector 3 to it. So it's adding a value to it, I'm adding -1 to the X value every time I press the A key on the keyboard. I'm adding 0 on the Y and 0 on the Z, so it's doing nothing there. But on every update, it's checking if I press a key. Now, if I press a key, it's going to apply -1 to my current values of the transform component for the position. So I'm subtracting basically every time I press A from its X position. All right. This is a very simple way to prototype that functionality. Now, you may want to set this up so that your cube keeps on moving consistently instead of on every click of the key. And the way you would do that is you'd use a simple API call. It's slightly different than get key down. It's just get key. Get key tells the computer or Unity to, on every frame that it detects that your key is down, it keeps on returning true. So in that case, it's going to say, if the user is holding down the key, keep on doing the code that exists within this block. All right. So now that I've changed it to get key and I press play, when I hold my key down, instead of tapping it multiple times, my cube's just going to keep on moving left. And there it goes. So I'm going to do that again really quickly just so you can see it. And I'm going to move my scene view so that you can see this from a very kind of high level here, literally. And I'm going to press play, and you're going to see my cube just shoot to the left here and then begin falling because gravity's applied. All right. I stop pressing left or the A key, and I just start moving straight down. So in that discussion, I've kind of given you guys a brief summary on how to use Unity, how to set up a basic scene, and then I've given you the code to begin implementing your simple 2D platformer. I'm not going to show you guys in this episode how to write the remainder of this code, because with this, you should have an idea of how to implement the next key detections. What I recommend you do is you take this code block and maybe you duplicate it to detect your other keys. If you want to detect the right arrow or the D key on WASD for movement, you can use the same functionality, and instead of moving in the negative X direction, so instead of appending -1 to your X stat, you can add a positive. Or if you want to detect spacebar, you can use the same thing, use keycode.space, and then you want to move your object on the Y every time it's pressed. So I'm going to let you guys experiment with that. That wraps up this tutorial on how to set up your project for implementing simple game mechanics for 2D platformers. And we're going to have another one up soon where we're going to go into a little more detail and show you guys how to implement using the get access functionality so that you can detect controller input as well. All right, have a good one, you guys.